Hi guys, I wanted to walk you through a simplified circuit analysis involving simplifying series and parallel circuits. So let's imagine we start with a battery. Let's say it's a 20-volt battery, so 20 volts. And it's connected to a simple network. Let's go ahead and draw it out here. And this simple network, the idea is to try to simplify the network so that it has an easier solution. So let's say this guy is 4 ohms, and this guy is 8 ohms, and this guy is, what do I think, 10 ohms, and this one over here is 14 ohms. Let's try that, right? And the question is, and we know there's going to be some current flow in this guy. We call this I1, some current in this branch, I2, current in this branch, let's call it I3, and of course I3 in the 14 ohm resistor as well. So the question is, looking at that circuit, is there a way to simplify it so that I can solve it more easily? Well, the only simple combination of resistors that exists in this circuit is the 10 ohm and the 14 ohm. Those guys are in series. So I can combine those two into a single resistance of 24 ohms. Because they're in series, I can simply add the resistances. So let's do that. Let's march this way. So we'll redraw our battery, 20. And then we'll redraw the 4 ohms. And then I'll simply replace the two series resistors with a single resistor whose resistance is the sum of those two. So this is going to be 8, and this is going to be 14. Notice now I've got an 8 and a 14 in, this guy's still going to be 4. I've got an 8 and a 14 in parallel, so I have to work that out. So R parallel is 1 over 1/8 plus 1, oh no, not 14, it's 24. Daggone it, hang on. (24). 14 plus 10 is 24. 24. Okay, so an eighth plus 24th, well that's 3 24ths plus a 24th, so that's 4 24ths. So that's going to be 24 divided by 4, which is going to be 6. So this is this 8 and this 24. We could simplify that and make it a 6. 6 and 4. Now, let's scrunch this up a little bit, move it up, and let's simplify the 4 and the 6 and make those guys into a 10. So what I have now is my 20 volts and a simple 10 ohm resistance. So this is 10, this is 20. And so you can see that circuit is quite simple. It's just going to have a current of 2 amps. 2 amps. Because 20 volts divided by 10 ohms is 2 amps. That means I can go back to this guy and I can replace the current here with 2 amps. Of course, this is 20 volts still. Now, if this is 2 amps, that means I can write in the voltage here. That's got to be 8 volts. And of course, this voltage has to be 12 volts. So I've learned that there's an 8 volt drop across the 4 ohm resistance and a 12 volt drop across the 6 ohm because the main branch current is 2 amps. But now I've learned, let's see, actually let's undo that. Now I've learned that the current in the main branch is 2 amps and the voltage across that parallel combination is 12 volts. That means that I can replace this guy with 12 volts. I know there's a 12 volt drop across this parallel combination over here, the 6 ohm parallel combination. So that means that there's also a 12 volt drop across the 8 and the 24 in the previous picture. So this is 12 volts. And of course, the voltage drop across the 4 we already learned was 8 volts. That tells me a lot, because if there's a 12-volt drop across the 24 ohm resistance, that tells me the current in this branch has to be half an amp. Okay, I know the current in the main branch is 2 amps, so I can use Kirchhoff's current law at that junction to deduce that the current down this middle branch has to be 1.5 amps. Or, alternatively, I could also check that by taking 12 volts divided by 8 ohms to get 1.5 amps. So the current works either way. I can take the voltage drop across the 8 ohm resistance and divide it by 8 ohms to get 1.5 amps, or I could take Kirchhoff's current law at the junction and check that I get the same answer. And indeed I must. So, and that leaves me back to my original circuit. I now know everything about this guy, because I know that I1 is 2 amps. I know I2 is 1.5 amps. I know the voltage drop across the 8 ohm resistance has to be 12 volts. I know the current down the side branch, I3, is half an amp. That means that the voltage drop across the 14 ohm, let's fit it in here somewhere, it has to be that has to be 7 volts. Because half an amp times 14 is 7 volts. And that means the voltage drop across the 10 ohm has got to be, there's two ways to work it. You can take half an amp times 10 ohms and get 5 volts. Or you can notice that the loop rule around this loop has to add up to 0. So if I go up 12 volts in the 8 ohm, if I start down here and I go up 12 volts through the 8 ohm, I've got to go down by 5 and down by 7. 5 plus 7 has to add up to 12 in order for the thing to work. So I can start down here, I go up by 12, down by 5, down by 7. That gives me the loop rule around this loop. And the current rule through this junction says that I go 2 amps is going in. I have half an amp going down this branch of 24 ohms. That means I have to have 1.5 amps going down this branch of 8 ohms. Anyway, that's the general idea. I hope that makes some sense to you guys. If you have any questions, please don't hesitate to ask.